Okay, so I've got a collar, frictionless on a rod there. It's released from rest at the point show where everything is undeformed in the springs. Okay, I got spring constant. I want to find the velocity after this thing moves down 100 millimeters or zero point 0.1 meters. So here's the deal. I'm trying to find velocity at a specific position. Velocity position, I use work energy. Only thing doing work here is gravity and springs, right? Gravity's pulling it down, springs are keeping it in position. Friction, it specifically says, is not there. It slides without friction. So if I only have gravity and springs, I can use conservation of energy. So I'll say KE1 plus PE1 equals KE2 plus PE2. Okay. KE1 goes to 0, released from rest. Okay. Now, position shown, things are undeformed, and that's where it's released from. Okay. So the springs in that position have 0 potential energy. Now, with gravity, I get to choose my datum. With a spring, I don't, right? There is no potential when it's undeformed. If it's deformed at all in any direction, I'm going to have a positive potential in that sort of a situation. But when they're undeformed, 0 potential. So I'm going to say at this point right here, I'm going to call my datum right here. So my complete potential energy at this point is going to be 0. Okay. And again, that's because by definition of how the spring, they're undeformed at this position. Okay, so those definitely have 0 potential. So I may as well force the gravity to be 0 at this point as well. So then I can have one complete 0 potential right there. Again, I do get to choose that, but I think that makes the most sense for this. I don't get to choose it for springs, so I'm just kind of using them as my guide for my datum here. Now, KE2, I really just have one mass here, and I'm trying to find its velocity, so it's just going to be 1/2 mv squared, where m is 4 and my v is what I'm looking for. Now comes my potential energy. So we'll start with gravity since it's the easy one. I am below my datum, okay? There's potential for gravity to do negative work to get it back to the datum, right? To get it back up to datum, I need to move up. Gravity goes down, negative potential below the datum. Okay, so it's going to be negative mgh, where m is 4, g is 9.8, and again, this is 0.1 down below. So after this thing has moved down 0.1, okay, now I've got 2 springs. Okay, so what's happened here is I'm at this new position here, which has moved down 0.1, and I have new lengths of springs here. Okay, initially, the length of each spring is 0.75, okay? Because it's a 3, 4, 5 triangle initially. If you don't believe me, you can look at it for yourself, okay? Now I have 2 springs, one like that, one like this, right? I'm going to let you on your own figure out, but again, now this is, for example, 0.5. This stays 0.45, right? I've got a triangle up here that is 0.7 now and 0.45. Okay, do Pythagorean theorem, and I get this side equal to 0.832 from Pythagorean theorem. The other one is 0.673. Okay, therefore the stretch on the bottom string is 0.75 minus 0.673, and I get 0.0773. Up on this one, I get 0.832 minus 0.75, and I get 0.0821. Okay, so just doing Pythagorean theorem, find the new length of the spring, find the actual stretch in the spring, because initially it's 0. The unstretched length is going to be 0.75. Okay, so now knowing those, I can find the potential energy in each spring. Potential energy for a spring is always positive because the spring's always pulling or pushing it in the direction to get it back to datum. So potential energy is always positive for a spring. So just keep that in mind. So one spring will be 1/2 ks squared, where it is 300 times 0.0821 squared. And then I have 1/2 times 300 times 0.0773 squared. Okay? Calculating that all out, my potential becomes negative 2.01, again, mainly due to the gravity that's happening, the fact that it's fallen down. Okay, so plugging that into the dot equation, my initial stuff is 0. I get 2v squared as my final potential, or that's kinetic. My final potential is negative 2.01. From that, I can calculate that the velocity would then be 1.003. So again, just recognizing that you just have gravity and springs, conservation of energy, okay? And then just doing a little geometry to figure out the new positions, new lengths of the springs, new stretch, will help you find the potential energy final, and you can easily calculate the final velocity then.